This is the OTG pulse generator circuit. It was released via a paper into the public domain in February. Quite a few people have replicated the circuit, but the paper doesn't really go into detail on how the circuit does what it does. It just shows how to build it. So I'll go through a few things and try and clear a few things up in this video. The circuit is designed to send a fixed width pulse to the base of an SSG transistor. These two ICs are CMOS 7555 timers. They're not standard bipolar 555 timers. The reason I use CMOS was because of the very low power consumption, and as a result of the low power consumption they can't really power anything with a great deal of current, so they can manage an LED on its own, unlike the bipolar 555 which can drive significant current up to 200 milliamps. So the purpose was to design a device that was very low power and would send a very short duration pulse to the base of the SSG transistor. This chip here is configured as an astable timer. It's an oscillator. It just goes high, low, high, low, high, low. The rate at which it does it is controlled by this capacitor, this resistor, and this potentiometer, which is in series with the resistor. So in its lowest resistance is a 10k resistor and a 0.1 UF capacitor, and that gives around about a frequency of 715 Hertz. What I'll do is I'll connect a scope probe to the circuit. Just pop the ground on the ground clip, it's all set out in the paper, and the probe positive on the output of the astable oscillator. Now what this is going to measure is the astable frequency. So if we go up to the scope, you can see that everything's going slow. I always start the scope up this way. I've got the time division on its lowest setting and the amplitude division on both channels on its highest setting, and intensity is reasonably low. That way I don't get any nasty surprises if I accidentally connect something up that's giving out too much voltage. So we'll just bring the frequency up. Amplitude division. Right, that's the output of the astable oscillator. It's a DC wave. If I just press the 0 line, you can see. We'll set that at the centre of the graticule, and there we go, with 2 volts per division. So we've got 2, 4, just 4.1, 4.2 volts, somewhere around there. If you choose AC, it tends to sit in the middle of the DC line, which isn't right, because we know it's DC. It's either on or off. There's no AC signal in this waveform. Right, as said before, this chip is the astable oscillator which controls the frequency of the circuit. It does it via this capacitor, that resistor, and the potentiometer. What that is an RC circuit which controls the frequency of the timer. It's not a normal method of wiring an astable oscillator with a 555. It's slightly unusual. It works very well with the CMOS chip, not so well with the bipolar, but it still functions fine. So we've got our capacitor and our resistor network for the frequency of this oscillator. As stated in the book, adjusting this increases or decreases the resistance, which in turn affects the frequency. I'll do that now. What I'm doing is I'm actually increasing the resistance which is increasing the frequency of the oscillator, and that gives us frequency control, and that is all this side of the circuit does. This side sets the frequency at which the monostable fires, back up to minimum resistance on the potentiometer. So that's the highest frequency, which I think I said was about 713 Hertz. Right, what I'll do now is I'll add a second probe, a channel B probe. Just plug that in there. Around there. Right, what we need to do is this needs to come off the output of the monostable, which is this chip here. So I'll just pop a small conductor into pin 3, which is where the diode comes out of, and clip onto there. Now I'll switch the second channel on, which is again DC. I'll put it on to, now I don't know if you saw that, but there's a small spot just at the top. That's the pulse that goes to the transistor. That's what the whole circuit is about, and it always occurs on the high to low transition of the A stable. It's what's called an edge triggered monostable circuit. Now this is our monostable timer. Now this will, once triggered, it will give one high pulse, and the length of that pulse is set by this resistor and this capacitor. In this circuit it's a 470 PF capacitor and a 10k resistor. What that gives us is a on duration of round about 4 microseconds, 3 or 4 microseconds. So it's triggered via this network here. The output pin 3 of the A stable is connected to this capacitor, which is also the opposite side of the capacitor is connected to the input of the monostable and this diode and 47k resistor, sorry, 4k7. And what this does is it gives a sharp spike every time the A stable goes from high to low. This capacitor is suddenly charged with a blip, and that blip is enough to trigger this monostable into an on state, which is set by those two, this resistor capacitor network here. And that's pretty much it. It's a very narrow pulse. I'll try and show you on the scope.